This is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST Robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
All right, I've got the recording started. Welcome, everyone. I think we have a few new faces on the call, which is always great to see. Hopefully, we'll have even more next week. I think we're going to have a light crowd tonight because the Granite City Regional is either still going or just got done. But we'll muddle forward as best we can. We were going to have a talk tonight led by No Mythic, but Michael Flood, who was planning to host that talk, is chasing an eclipse. So he is out of town at the moment. So I decided that I would step in and give an LED talk that I had been procrastinating about for quite a while, and I forced myself to finally pull it together. And tonight we're going to talk about how Nightcrawler puts LEDs on their robots, and we would love to have anyone else who's willing to share their team's approach or sample code or anything that you're interested in sharing. Please don't hesitate to jump in either in the middle if you've got something to inject, or if at the end, if you want to take over screen sharing and share something you've got. That'd be awesome to have other teams providing some input on what they're doing. So to get started here, I'm going to be taking my camera off my laptop and kind of showing you around my sort of a wiring bench that I've got set up in my office, and hopefully that's not too disruptive for everyone. I've never done this before, so we'll see how it goes. But I am, Ian's on the road too. I am going to share a link in the chat. So that there, if you go to team2052.com/LED, I just published about 5 minutes ago. This new webpage that's on our website, and most of what we're going to be doing is going to be covered on this webpage. It's very verbose and probably full of grammar issues because I completely ran out of time today to do any good spell checking or anything like that. But a lot of what we're going to be doing, I tried to get published today on our website. It's team2052.com/LED. And that is what we're going to cover. I've got my setup in the back here, and we'll be going through sort of how this thing all works. I'm going to start with some screen sharing so that I can kind of talk through some of these photos here. So let me start with that. All right, I want to share this screen, I think. Let's see if this works. All right, so you guys can see me. Now can you see the web page? Yep, looks like you can see it. So this is sort of a top-down view of our LED setup. When we talk about the goals of LEDs, we tried to do LEDs on Nightcrawler for a couple of different years. We made a lot of black smoke or magic smoke and a lot of burned out circuits trying to do LEDs. We tried it a few different ways. We tried a LED controller, I think from CTRE, and someone wired that backwards and burned it up. And that's not a cheap little controller. And we sort of got frustrated with how we were trying to do things. And so a couple of mentors put their heads together and said, let's see if we can come up with a rig that's sort of foolproof. Our objectives were that we wanted to buy cheap LEDs. So that means we wanted to buy the 5-volt LEDs, not the 12-volt automotive LEDs. That required us to be able to have a 12-volt to 5-volt step-down converter in order to run those LEDs. We also, one of our goals was we wanted to make it so that we could take the entire LED setup and set it on a table and hook it up to a robot battery, and any programming student could learn how to write code to run LEDs without having to be connected to the robot. We wanted the same system to be sort of portable so that if we wanted to put LEDs on the robot cart, if we wanted to put LEDs on the pit, if we wanted to put LEDs around a display that we were doing at a farmer's market or some other fundraising event, that you could just pick it up and go, and all you needed was a laptop battery. Another requirement we had, and something that really scared us, is that if you were running wiring, if you were powering your Arduino or whatever it was you're using, in our case, we're using an ESP32 chip. If you're powering an ESP32 chip, we didn't want to run the risk that you could accidentally run 12 volts into a USB port in your laptop and either destroy your laptop or burn up your USB port. So we also wanted to make sure that we were always powering the Arduino or ESP32 processor off of a USB connection. And the nice thing about that is, and you can see in this photo, actually, let me scroll down here a little bit. That's the wiring. If you look at this photo right here, so this photo right here, we've got the ESP32 is plugged into a USB cable, and that USB cable is plugged into a little USB port that is sort of what you would see has maybe replacing a cigarette lighter in a vehicle. What you could do then is that you could just unplug that from that USB port, plug it into your laptop, deploy new code, and then you could run your LEDs with the ESP32 being powered from your laptop and the LED lights being powered from the robot battery. And that's a pretty simple thing to do. All you need is a common ground, and that becomes possible. So we wanted to make it super trivial and super easy for students to be able to test code, try code, test code, and then be able to just unplug it from your laptop, plug it right into that little port that's on the left there, and everything just goes and just works. What else can I tell you about goals? Another goal that we had was we wanted to make talking to the RoboRio simple. And what I mean by simple is we want it to be sort of easy to understand for a new programmer or a novice programmer. I think a lot of teams are probably talking between their RoboRio and their Arduino using I2C protocol or an SPI protocol, which are both sort of serial communications. And that's a better way to talk between the two chips. It's a more standardized way to talk between those two chips. But if your processor isn't doing what you think it should do, it can be really tricky to debug if you're not an expert in that system. And so we wanted to make something simple that was easy to wire and would also work with a test rig without having to hook up another computer or another Arduino so that you had two processors talking to each other. We wanted something simple. And what we came up with was we wanted to use DIO. And so on an Arduino or on the RoboRio, you have 9 or is it 10 DIO ports on your RoboRio? And most people are connecting limit switches to that, or more maybe a beam sensor or something to that to their RoboRio's DIO. And I would guess it's probably uncommon for robotics teams to have all of those DIO ports filled up on the RoboRio. In our case this year, we had 4 open spots on our DIO rail on the RoboRio, and that gives us up to 16 different light modes. So that's more than enough for what we were trying to accomplish, and I think that's probably pretty similar for a lot of teams. So we wanted to use the DIO, and I'll talk a little bit more about that in a minute, but each one of those pins in the DIO represents a binary number. So if you're familiar with binary, it's basically counting by powers of 2. The first one is a 1 or 0. The second one is a 0 or a 2. The second one's a 0 or a 4, and you just add those all up. And if I'm going too fast, we'll get to that in a minute when I show the actual demo. So those were our primary objectives. We wanted basically this thing that you could pick up, you could walk over to the table, plug in a battery, and be able to run LEDs. So now that I've kind of given you an idea of the goals, let me show you this thing in action. I'm going to stop sharing. I'm going to bring my camera around here, and let me show you the parts first. So this is the USB thing that you just power off of a 12-volt battery, and it gives you a regular USB 5 volts on it. And the links to all this stuff is on Amazon if you want to just go buy exactly what we're doing. This is a 12 volt to 5 volt step down converter. So 12 volt goes in one side, 5 volts comes out the other side, and it can power up to 3 amps. And that's pretty much everything you would need to run pretty much any single LED strip. This 3 amps would be more than enough. You can run all that. In fact, this is a rig that we kind of pulled off of a laptop. Maybe it'd be better if I put this on the floor. It's basically just in a wire. And if your robot looks like our robot, it's just a mess of wires laying in the bottom of the robot. And so you can get by with not having this big, gigantic, bulky case on your robot if you don't want to. But this works really nice for a testing setup. Now tonight I don't have a robot battery with me, but I've got a benchtop power supply. So I'm going to turn that power supply on. And you can see that I think you guys can, it's backwards for me, but I think it's forward for you guys, right? So this is showing that my battery is at 12.1 volts. And I've got I got a debug display here showing code 0. So let me show you what I mean by the binary part of this whole thing. This top rail right here, let me see if I can get the camera on. This is a grounding bar. And so we have our code set so our pins are using a built-up pull-up resistor. What that basically means, let's see here. Do I want to cover that now? Yeah, let's talk about pull-up. So I'm going to use my hands, I think, to demonstrate this. If you're new to circuits, this is a closed circuit where you're completed connection. So let's say you've got something over here that's reading the pin and something over here that's supplying either a ground or a power source. And so when the circuit's open, it's called floating. There's nothing to read because the circuit's open. And so you're sort of trying to read air. And if you're doing small microelectronic things and you're trying to read air, that's what we call a floating pin. So what will happen a lot of times is it'll sort of fluctuate, and sometimes the pin will read high, which will be maximum voltage, 3.3 voltage, and sometimes it'll read low, which is 0 volts, but it'll sort of fluctuate. And that's no good if you're trying to write code. So there's a concept called a pull-up resistor, and what happens is that internal to the circuit, or you can actually use a resistor to do this, but what happens is if the circuit's open, it'll force the pin to always read high, which is the 3.3 volts. And so when a pin reads high, that means it's quote unquote on, maybe. And then when you close the circuit, if this is going to a ground, that will force the pin to go low, which will be 0, and you'll be reading ground. So think about it this way: do I see high voltage or do I see no voltage? And when you close the circuit and it goes to ground. So that's what we're doing here with these pins, is that top bar is the ground. And so I'm connecting the pin on the ESP32, that Arduino chip. I'm connecting that to ground, so now I can read 0. When it's floating, it'll read 1. And so that's how I know whether the circuit's open or closed or not, is by whether the pin is reading 0 or it's reading 1. Okay, so let's say that I'm going to take this first pin here. Let's see if you guys can see this. I'm going to put the first spot in the little pin header. I'm going to make it read. So there, see how it says code 1? Because I connected the first pin. So that's 2 to the first power, or to the 0th power, which is 1. Pin 0 is reading to ground. And so now my LED circuit is showing me lighting pattern number 1. If I connect the second one here to the second pin, let's see if I can get this in here without shaking the camera too much. Now the code is reading 3. Hopefully you guys can see that, because 2 to the 0th power plus 2 to the first power is 1 plus 2 equals 3. So that's reading code 3. And now my LEDs are showing me my third pattern. I don't know if the colors are coming through very well, but that first one was a blinky red. And this one is a kind of double pulsing orange. And so this is our pattern for we have picked up a note. The first blinky red one is a pattern for there's a problem. So maybe we lost our camera feed, or maybe something else is going on. And so it's sort of our danger mode. We've got some other fun patterns in here. I don't remember. This is code 2. This is we are currently intaking. Code 10 is going to be 2 plus 8. Let me see if I can get code 10. So those code 10. Come on, focus. Code 10. Code 10 is like ice. It's kind of a blue fire. And that's what we show at the start of auto when we're disabled, but we have an auto selected. And if I change this to code 9, so I put it in pin 0 and in pin 4, now I've got police mode, and police mode means you're disabled, but you have not selected an auto. So this is a great way that we use to get LEDs on our robot. We only have 50 LEDs on our robot, so we've cut a strip which normally contains 255 lights. We've cut it to the first 50 because that's what we needed to go around the upper frame of our robot. And so we just put 50 LEDs on the robot, and we're using these lights to show different states on the robot. One of the things that we talked about, the kids had talked about putting LEDs on the robot for a really, really long time. And Nate Smeal, who's our longtime mentor for the team, had always said, no, we're not putting LEDs on a robot. That's a waste of time. It's a waste of electricity. We need to focus on making the robot do awesome things. And we finally convinced Nate that LEDs in the robot could be a good thing because it can tell us what's going on with the robot. So one of the things I really like to do with the LEDs is to show the different states of what the robot is doing, because when something goes wrong, the first thing that happens is the coaches up in the stands and the programmers up in the stands, or the build students up in the stands will say, what happened? But if you can see the LEDs and you can see that we missed the shot low, but the LEDs are showing us that the camera said you weren't aimed yet and you still pulled the trigger and shot towards the goal, you'll know that, our driver needs to take more time and let the robot line up before he or she pulls the trigger to fire the game element. Or we can see something like the intake's not running. Well, maybe the intake's not running because it thinks you already have a note, or maybe you actually do already have a note and the driver doesn't realize it. And so now with the LEDs doing that pulsing orange, we know the second we picked up, as soon as we have picked up a note, the robot starts pulsing orange and we know we've got one. If the LEDs are blinking blue, we know we're running the intake and we're trying to pick up a note. So that's sort of an overview of why we do LEDs. It's sort of an overview of how you can take this testing rig here and set it on a table and test all of these different modes before you deploy it to your robot. I can go through the code and show everybody some of the code and give you some of the tips, but I think this is a good place to stop. Does anyone have any questions about everything I've said so far about why we chose to do the things we chose, how we decided on our LED patterns, or what type of things we do? What questions does this create?
So I got a couple. First thing is, you chose 4 pins under the assumption that most people will actually have 4 pins on the Rio that can be used for this. Mm-hmm. Do you have any way of adjusting that, or that sounds like a complete redesign of the communication channel if that's not true and you got to do PWI or something like that?
Yeah, I mean, if you have all 9 or 10 of your DIO pins completely filled up, you're going to have to use SPI or I2C in order to communicate with your chip. So I know that I see Keith is on here. Keith, you and I were talking about this. You guys use I2C. Can you share a little advice on how you communicate instead of using a binary system, how you use a more standard serial protocol?
Okay, so we've been doing lights for years. We did Arduinos for a long time. Arduino has a good I2C library, wire protocol. So I sort of modeled everything after that. And of course, the Rover Rio has good I2C as well. So at the moment, we're not using Arduinos. We're using effectively Raspberry Pi Picos, or the equivalents with Adafruit Feather, but they all speak I2C, and the Rio speaks I2C. Testing it does become a problem. So I ended up wiring a separate Arduino that talks I2C just so I can test all the possible patterns. So I've had to spend time with it, but it's definitely workable.
So the second question was the 16 you choose. I don't know enough about these LED strips. How many different patterns do they support?
I'll show you some of the code, but all of these patterns here were programmed by the students or myself. I would go out, like, for example, we have a fire pattern, that blue icy fire pattern. I just found that on the internet. I just copied it in as the sample to show the kids how we could do it.
Oh,
But like this here, one of our students, Sophomia, created this double pulse thing with 2 different colors. And so these patterns are programmed by our students, and I'll show some of the code of how that happens.
it's got to be a shift register based thing, right?
Yeah.
Okay.
Yeah.
I
Yep.
didn't make that connection. Okay.
Yeah.
And then
They're
the
fully.
last,
Go ahead. Sorry.
I was just going to continue your thought. I was going to move on to a new thing.
So we use a library called Fast LED. There's actually quite a few different LED libraries out there, but we use a library called Fast LED. And so this is, I believe, if I remember watching Afomia do this, that we were moving a 3 or a 4 block pattern down the stream. And then on every cycle, which I think was 10 or 20 milliseconds, it would fade all the pixels that had been lit up by 10%. And so that's how you see this sort of the trailing off part of this, is that you're shifting 1 block all the way down, but then you're not turning off the lights behind it. You're just fading them gradually so they kind of fade out. And it's a really simple piece of code, and I can show some of that code before we're done here. But go ahead, ask your question.
Your printables link for your models doesn't go anywhere.
Oh, it doesn't. All right. Well, I'll get that updated then. That's surprising. Maybe that's not public yet. Ben, you have access to our printables page. Maybe you can see if maybe that's not public yet.
Yeah, I'll log in and take a look.
Maybe that's the problem. Well, I've got you here. I already mentioned the fire mode. Let's see if I can figure out which one was fire mode. I think it might be 10 or 11. There you go. There's the fire mode. So this was the fire mode that I found somebody online that had done fire. And so I just copied the code into our library to show the kids how it worked. And then for the blue, all we did is we just took the red and blue channel and we just swapped them, and then it turned blue. Yeah, so I will show some of that code. I'll show you how easy it is. I also have on the website, on the 2052.com/LED page, on the bottom, I ran out of time today because I was going to put in and explain all the LED code. I will get that done at some point, but we use, there's a YouTube channel called Dave's Garage, and he's an ex-Microsofty, and he does all kinds of neat stuff like this. And he had a really good LED tutorial using a plugin for Visual Studio Code called Platform IO. We really like Platform IO a lot. It allows you to bring in libraries, really simple for Arduino. It's a really nice way to do it. And instead of most people that are doing Arduino code are doing everything in one INO file. And he writes this as regular C++ code. And so you can have separate files and separate classes. And his tutorials are really good. And he shows how to do some really neat effects on his channel. In fact, I think this fire code might be his. I think I may have copied his fire code when I brought it into the code to show the students how some of this stuff works. Good questions, Chip. So yeah, if you are out of DIO pens and this just is not going to be an option for you, doing something with I2C and setting up a second Arduino so you can communicate back and forth is always an option. And then you can plug it into your RoboRio's I2C ports, and then you'll be able to talk using the I2C protocol to your Arduino chip, and you can send and receive that way. The nice thing about I2C is that you could actually have the Arduino talk back to the RoboRio, where in this case it's purely read. So all you're going to have in using these DIO pins is the Arduino, the RoboRio is going to light up 5, and the Arduino is going to read those pins and show light pattern number 5. So there's definitely pros and cons. Our goal was to have a simple setup, and this is what we chose, but it's definitely not the best way.
Back.
I'm sorry, back.
It's unclear with a two-way communication what LEDs would say back, other than what they're currently set to, I guess, maybe.
Yeah, I agree. I mean, I'm not sure why you would communicate back. but at least it would be an option, right? I'm not
Previously-
saying the wrong things, right, Keith?
Oh, well, I'm no I2C expert, but we've previously used sensors. So
Is it just me or is he breaking up?
Yeah, Keith, you're breaking up on us. You must have a mic, something going on with your mic.
Okay.
Well, let's just see if we can get it fixed, and then we'll come back to you in a minute. Any other questions
All right.
about the whole setup here? Oh, try it now, Keith.
I think not.
That looks better. That sounds a little better. Try it. Keep going.
You.
No, it's still breaking up. All right.
Is to handle some time of play. So that's an entirely different purpose, but it's a situation of using a microcontroller to communicate to the Rios, and then we'd be sending data back. Actually, I think we use SPI for that.
Can you say that one more time? You use what for that?
SPI?
Oh, SPI. Another serial protocol. So, I mean, there's no reason why you couldn't. I think what Keith's saying here is that if you wanted to hook up a bunch of limit switches or something to your Arduino or other sensors, and then you could have your Arduino or Raspberry Pi or whatever you wanted to communicate back to your RoboRio if you need to take some processing power off. I mean, that's why we run Photon Vision on a different chip to take some processing off of the RoboRio. That would be an option. Anyone else have any questions about sort of the hardware setup here before I move on to some code?
Not a question, but I just fixed the link, so it should be up now.
Oh, excellent. So that printables link has this big, ginormous testing rig here. We do not actually put this big box on a robot. I have not put it on printables yet. That was another thing I didn't get done today. But we have a very small case that just surrounds this tiny little chip. This ESP32 is very small. It's about 1.5 inches by 1 inch. And we have a case that just surrounds that ESP32. And we just drop that in the bottom on a piece of Velcro, and we just drop it in the bottom of our belly pan. And then our 2 power converters, we just zip tie those to the side of the frame so that we don't put a big piece of 3D printed plastic and all that stuff inside of a robot. I had another chip here I was going to show tonight. Oh,
Scott, is that case that we use, is that an Onshape?
The what?
The case for the one that we actually put in the robot?
It's in I think it's in the 2020. No, it's in there's like an LED folder in Onshape in our.
Okay, I can put the link in chat if I find it. Okay.
This is actually the chip that we have on the robot. So this is another ESP32. It's made by Heltec. It's made by Heltec right there. This is the one that we have on our robot right now, and it has an integrated screen, which is really nice and really convenient. The problem is that this screen is communicated with I2C. And so a lot of these little OLED screens that you can get for Arduino are I2C screens. And I believe I'm pretty sure it's a software implementation of I2C instead of connecting to the clock and the data pins that are right on the chip. And because of that, the update is really slow. And so what we found we had to do is that when the signal comes in to change the number, so let's say that you're showing a 5, which might mean something like I'm aiming, and then you say go to number 6 because you are correctly aligned. It would take as much as a half a second to update the display, and a half a second is longer than you probably want in order to let your driver know that they can go ahead and fire. And so we ended up doing on the robot chip, because we already had this set up and we didn't want to take it off, is we would first change the light pattern and then we would update display, and we would only ever update the display if the number had changed. And so that display that you saw on the other one that says code 5 and code 4, that display is built into this chip. But unfortunately, the libraries that do the OLED writing to the screen, if the chip that you're sending it to is not connected to a hardware signal or hardware pin in the processor and it's using a virtualized thing, a software version, it can be really slow to update. And so it's best if you get a screen that has a hardware interface instead of a virtualized software interface. So let's talk about the code. I think what I'll do here is I'll show off our Java code first. Let me get that window back. Let's see here. So now I got to try to share with the Java. I'm going to try not that window. Not that window. Let me see if I can share this whole screen. What do you guys see now? Okay, I think it's going to work correctly. Yep. So then I need my robot code. All right, so Caleb, who's our lead programmer. Wait, by the way, is Caleb here tonight? I think he said he had tons of homework to catch up on. I don't think Caleb joined. So I'll give you a rundown of the code that Caleb has written. And now I have to figure out how to, who knows how to make font size bigger? Is it just Control Plus?
Control scroll wheel. There you go.
Control Plus work too. All right. So hopefully that's big enough for everybody. Let's hit the highlights here. So on the RoboRio, you just do a digital output and then whatever pin you're going to use. On our RoboRio, it looks like we're using pins 3, 4, 5, and 6 to send out the LEDs. As I said, that gives you up to 16 different light modes, 15 if one of them is off. So if 0 means off, then you have 15 different light modes that you can send. We did this the first year, and we had 32 pins, or 32 different light modes because we had 5 pins. And my programmer that year was very frustrated that he could only do 31 unique light modes. And I had to ask him how he was expecting everyone to memorize the 31 different light modes and what they all meant for robot status. That was kind of funny, but it was awesome that he got so excited about it that he created so many light modes, and then I had to pare him back to just 31. In the code here, so you create these DIO outputs, and then you have the pin specified. And what Caleb decided to do was to implement an enum. And so each enum represents a different status that we want to show. So he created an enum which had a code associated with it. And so these are the different enums that we have. We have off, danger. The danger one would indicate that there's a problem. This one's super helpful, actually. In 2020, I think it was, or maybe it was 2022, we had an issue. We were using the Limelight, and occasionally the Limelight feed would drop out. And so we were watching the Limelight feed to see when it had been updated. And if we ever lost our camera, what we would do is we would start blinking this danger light signal. And we were lined up in ELIMS one year, and they were just about to close the gate, and someone turned around and noticed that the robot was flashing red really fast. And we very quickly pulled our robot off to the side and ran a do not, or cross the line auto, because we didn't have a camera, so we couldn't aim. And then we put in one of our other alliance partners took the better spot, and they picked up and scored 3 or 4 game elements instead of us. And if we hadn't had that LED mode, we would have never known that we had lost our camera feed, and we would have ended up with a really bad auto score for an ELIMS match. And autos, are important for ELIMS. So we have a status here for we're intaking. We're having a status for I have a note, aiming. When you're aiming and you're on target, then we have shooting, and then shooting on target. So sometimes we have a button that our driver can hold to aim the robot, and then a separate button to shoot. And so if we ever see the shooting mode happen, which I believe is white, instead of green, which is shooting on target, we'll know that our driver was shooting and it wasn't on target yet. Or maybe he was shooting and he got hit, the robot got hit, and the lights would go white before the game element would come out, and then we'd know what happened there. We also have a done shooting here. This basically just means that the robot doesn't think it has a note and you're running the shooter. Now, maybe that's because you're actually done shooting, or maybe we lost a sensor or the game element's not aligned properly. And then we have these auto modes. So This is very helpful too, because you put your robot in the field, and if you forget to select your auto, you'll see the police lights that I had on behind me a minute ago. And once you have an auto selected, if you're on the blue side, it'll show you the blue fire. And if you're on the red side, it'll show you the red fire. And then we added a status later. We have an idle speed for our shooter, and we have to run that back, one of the wheels backwards when we're going to amp. And so this light indicates that you're running idle, but you're running it in reverse because you're running it for amp. So in our system, in our LED system here, we use that as a singleton, this LED subsystem. We use it as a singleton. And if you're not a programmer and singleton doesn't, or even if you are, and singleton doesn't make any sense for you, what a singleton is basically this class can only exist once. Nobody can make a new instance of this class. It can only be created one time. So you'll notice that the class itself, where is the constructor? I think the constructor should be in here in private. Oh, there, right here. Yep. The constructor right here is private. And you may be asking yourself, how in the world can you have a class with a private constructor? You could never create it. Well, what happens here is that this class can basically only be created by itself. And so you create a static class, which means you can access this method without there being an instance of the class created. And it will check to see if it has an instance. If it doesn't, an internal private instance, it'll create an instance and it'll give that instance back. And so this is a very common programming pattern. A lot of teams use this for all of their subsystems. So the only way you can get access to a subsystem is to ask for its instance. But if this is a new concept to you, I recommend you go out and Google singletons and learn about the singleton pattern. But what this allows us to do is that any code from anywhere can say LED subsystem.getInstance.setMode, and you can change the LED light mode from anywhere. It's a really convenient way to do something like this, where you never want to have two copies of the same class fighting for a physical resource like a motor, or in this case, like lights. So I'm going to skip this periodic for a minute. We have the ability to directly set the color. So if you want to set the status mode from anywhere, you can just set the status mode, and then you can see what it has been set to. You can clear it, which just sends it to off. And then we have this concept of disabling or enabling the LEDs. And this is probably not well named. This is really enabling or disabling the periodic. So because this is a subsystem, it has a loop, and it runs every time the scheduler runs in Robot Container. And if the periodic evaluation is not disabled, then it'll go through and it will check to see what lights it should show. So for our robot code, Caleb implemented this thing for us, which I think might be new this year, or maybe it was new last year, called Robot State. And so he will ask Robot State. So he'll ask Robot State. It's also a singleton. He'll ask, what is the status of the champer, which is our shooter amper. He'll ask, what is the status of the goal angle? And so all of our subsystems can report important information to the Robot State, and then that can be accessed from anywhere. So if you're in the disabled mode, we need to know, what are you doing for autos? So we'll show the police mode for, hey, you failed to select an auto, or we'll show red or blue, or we'll show off. I don't even know if it's possible for it to be off, since you either are red or you are blue. Unless it's unable to get this from the driver station for some reason. If you're not disabled, then it's going to check to see if you're in the autonomous period. And he's asking to see if there's a note detected, if your champer's at the goal angle. None of this is super important for how things work, but it kind of gives you an idea of the flow of the code and how Caleb has set this up to run our LEDs. He's just setting statuses. So he's setting, this is the current status mode that we want to display for the color. So this is the enum. He's then pulling out the integer value for the code. So code lives in our integer variable. And then he's sending it out to Smart Dashboard, so we can kind of see what's being sent down the down the wires to the Arduino. And then we're using a bitwise AND. So for those of you who aren't familiar with bitwise AND, this integer, if you represented it in binary, let's say that you represented the number 3 in binary, that would be 110050. So 1 or 6 zeros. 1 1, which is 1 and 2. So together that equals 3, and then 6 zeros that follow. So we're doing a bitwise AND with the number 1. And so what this means is that if you overlaid the binary for your value, so let's say 3, with the value for 1, would it return any matches? And so if nothing matches, you're going to get back a 0. If anything matches, then you're going to get back the bit that matches. And that's what a bitwise AND is. So in this case, if you overlaid the code that you want to send with the number 1, then you should send a signal on number 1. And if you overlaid the number 2 on the code you want to send and you get anything back, then you should send a signal for number 2. There is one thing with this code that we're considering changing, is that when you say set, and if you give it a value greater than 1, you're going to send voltage. And I said earlier that if the circuit's open, we use a pull-up resistor, and that will send you a high signal, or it'll actually send you voltage. Well, in this case, we're sending voltage for it's on and no voltage for it's off. So we're thinking about changing this so that we always send voltage on unless there's a match, and then we'll send no voltage or ground, so that the logic works the same for the testing rig as it does for the robot rig. I'll show you in the Arduino code, we actually have to have a condition that says, is this code running for the robot, or is this code running for the test rig, so it can evaluate the logic differently. And that kind of stinks. But it makes more logical sense for humans to think that if something's on, you send it a 1, and if it's off, you send it a 0. So that is one sort of mismatch with electrical, is that pulling high means by default be true, which is unfortunate. So that's the Java code. Before I move on, does anybody have any questions on the Java code?
I do.
Yeah.
Can you go back to the part where you're starting to look at the various status outputs?
This part right here?
No. The very beginning of this. So what it's asking for is driver station, and then it's looking for auto, no auto.
Yep.
And
So if let's
down.
Okay, go down.
On auto, no auto is the value that was sent from whatever class you have for autonomous management, saying I don't have autos. Yes.
Yeah. So
Yes.
this dashboard.getInstance.getAuto, this would be looking at the drop-down list you would have in Smart Dashboard, where you would select your auto.
Yes.
So that would be what's that called in something chooser? Is that called a smart chooser or whatever?
So go down to where you're starting to look at your actual robot. So
should we do it in Teleop LEDs?
So the robot state. Who is robot state?
So robot state is a class. If you go to definition on this, robot state is a class that I don't know if Caleb invented it or if one of our other students invented it, but it was basically a way that we could have one place to go to see all the important things about the robot. So for example, this chassis speed, this is how fast we're driving. Somewhere the drivetrain is updating robot state, saying here's how fast we're going. So the nice thing about this, and again, robot state is a singleton. So here's our whole singleton implementation. That means that this is accessible from anywhere without holding an instance to it. So you wouldn't want to give everybody access to your drivetrain, right? Because you don't want other people talking to you don't want other classes. You wouldn't want your shooter to know anything about your drivetrain. So instead, you can do this kind of informational update or status update to robot state. And then anything that might care how fast you're driving can ask robot state, how fast are we going?
Yes.
This is important for things like APL tags.
This is essentially an implementation of the publisher subscriber model.
Yeah.
And that way the drivetrain can publish, doesn't care who's going to read it. The other guy can read it, doesn't care who's updating it. That is brilliant. I really like that.
And I will say that I'm not a big fan of what I would call the pure pub sub model that a lot of developers are using, because you can lose track of who's subscribing. But this is much simpler,
yes,
and also very fast as well, because now you're not sending messages that a bunch of different things have to capture and decide whether they care about it or not.
Yeah.
But the singleton is a very, very, very powerful pattern. And if your team's not using it, I definitely encourage you to look into it, because you really don't want to be passing around a handle to your drivetrain everywhere or to your shooter everywhere. But there's some times when different classes might need to know, hey, if I'm shooting, I don't want to run my intake right now, or something like that. So this is a great way for all the different subsystems to kind of report, here's what's going on with me. And then other things can use that if they want to. And I believe here in Robot State, everything that gets published in here also gets pushed out to the network tables somewhere. I'm not 100% sure on how that
make
happens.
A great deal of sense.
But I'm pretty sure he probably has that in here, or maybe Afomia, maybe she did all that. They're pushing it out to the network tables too.
This is my first year looking at this code base. I've been doing a lot of FTC, but I was very surprised that the subsystems were not singletons. I didn't quite understand why they wouldn't have done that, because they clearly have to be singletons in practice.
Yeah, I agree. But it is sort of that next level programming concept, right? And we're teaching kids brand new concepts. And quite frankly, some adults are learning this for the first time too. So I can see how as a mentor or as a student, you would leave that out of the mix, because it just adds one more layer of complexity. But we found that it only takes a couple of times of putting it together on the whiteboard for students to kind of get it. And once they've been through a season with singletons, it all really starts to make a lot of sense for them. It doesn't seem to take very long, but when you're going through sample code for the very first time, throwing singletons and statics into the mix can really kind of mess people up a little bit. So I can see why it's not in any of the sample code that you see from first. All right. Well, great question. Does anyone else have any questions about how our RoboRio is deciding to send the signal for show this light code or show that light code, or what that means in terms of like this binary bitwise and? Bitwise and is, again, not a very familiar concept until people go to college and they go through Computer Science 101, I suppose. But once you sort of get the basics of it, and you can do a YouTube, I'm sure you can find way better explanations on YouTube of bitwise and than I've given in this last few minutes. All right, so then let's look at some LED code. So is this our LED code? Oh, it's so small. I guess this is it. So let me see if I can scroll in this. And I know, I think I saw Ian left the call. Ian would yell at me because I'm running in light mode. But I'm old. And so sometimes I like to see things in light mode. Okay, so when you do Platform I/O, I don't want to give an instruction on Platform I/O, but I'll give a brief overview here. By the way, Dave's Garage, great tutorial series, and he uses Platform I/O, and that's what we use to learn it. But with Platform I/O, you specify the chipset you're compiling for. So you can see here on line 11, this is the Heltic. That's the chip that we have on a robot. And then this UPESI W room, this is the chip that we have in our testing rig. And then actually this is Platform Espressif. I suspect this does not matter. Oh no, that's fine. But the framework is Arduino. So we are going to compile and run Arduino code. And if our dev kit, we have the board is UPESI, UPESI, and the board here is Heltic. So you can set up a Platform INI file, and then you just have to pick your board. There's a whole tutorial on how to do that on the Dave's Garage thing, or you can find other ones on how to use Platform I/O for Arduino. I don't want to go into that, but this basically tells you what development processor, the ESP32 you're using, and it compiles for that. This also shows you the libraries you're using too. So we're using this library here to talk to our OLED, a little OLED display. And then this is the library that we're using to control our LEDs. But first thing I want to do here is I want to take a quick look at our main CPP. So this is your main C++ code. By the way, if you didn't know this, all Arduino code that you find, well, I don't know, maybe all is not the right word. The Arduino code that you find on the internet, it's C++, or maybe it's C. And so this just is very explicit that this is a C++ file. You can see here that we've defined constants that match the constants that we have in our RoboRio code. And then in here, this is all fast LED code. So we're creating our C RGB. So this is an array of LEDs, I guess. They're individually addressable. And we have a constant set up for the number of LEDs, which currently is set to 50. But if you wanted to light up the whole string, you could do that. We're keeping track of the last code that the RoboRio or our little jumper wire sent us, and we're doing that so that we only ever update the screen when that changes. We have a pen reader class. I'm going to go in there and we'll look at that in a minute. Oh, this last screen update, this is milliseconds since you turned on the Arduino. An unsigned long, I think, is more than a decade. So in terms of milliseconds, you could leave this thing on for 10 years and this thing would not run beyond the limits of an unsigned long in terms of milliseconds. And then this is the object for our screen. Again, I'm not going to go into how you make a screen update. I'll get that all commented in the sample code. But if you go out and you look for tutorials or examples on the U8G2. I have no idea what this means, but the U8G2 is a very common library that people use to talk to tiny little displays. There's tons and tons of good tutorials on there, and you have to find the driver, which is what this is, that matches your screen. And so for this is saying that I'm using a screen that has 128 by 64 little pixels on it. And you can see that this is using a software implementation instead of this one up here uses a hardware implementation. Actually, this can't be the most up-to-date one. We probably have, I haven't pulled the code that we fixed because we have it so you can switch it back and forth between the testing rig and the hardware rig much easier. Doesn't matter for this. We create a class for all of our different ways that we can control the LED. So we have this pulse, which is this that runs back and forth. We have beats. I think that one is similar to pulse, but it goes in both directions, or it does two pulses that go opposite each other. I forget what bounce is. I think Afomia made bounce. And then there's a twinkle, which just kind of lights it up in different things, and they start fading in different areas, and it starts fading out. Update code on screen. We just call this every time and say, here's the code, and it checks to see if it matches, if it's different than the last code we sent. And if it is, then we call these methods to send out to the screen. Again, this is not important. You can copy all this code, but there's tons and tons of tutorials that you can find on this GOLED or the UHG2. You can change the font sizes. You can actually draw any shape that you want on the screen. It's not limited to text. It's really neat. There's a lot of stuff you can play with there, but for us, we're just using it as a debug thing. So we're just going to print out code space and then whatever the value was that the code came in as. So code 2, code 10, whatever the case may be. So we have two main parts of our LED stuff. Usually you want to initialize your light pattern, and then you want to run that on a loop. And so sometimes with your light pattern, you're going to just go solid and then fade it all to black, and then maybe go solid and fade it all to black again. So maybe usually with you, when you initialize a light pattern, you're going to clear whatever the light pattern is to start. Fast LED, you just say show, and that sends that to every single LED in the chain. So in our case, we have 50 LEDs. And so you've cleared them, which basically turns them all off. And then you just call show, and then they all go off. Then we're going to reset our brightness back to our brightness factor. So this is a constant. It's just 255. And then we're going to go through which code did you want to do. So this is just basic programming. We have a switch statement here for what is the code. If the code is 1, which is our constant for danger, then what we're going to do is we're going to tell our pulse to initialize using the red color, and we want to run on a 20 millisecond loop. And let's just go look at pulse. We'll go look at pulse as one of our first ones. And all these other ones are the same thing too. This has note 1, that's that double pulsing orange. This does a beats. I guess it takes up to 4 colors, but we're using the exact same color for all 4 colors because we want it to all be orange. So it's doing this like quadruple pulsing back and forth, but it's all orange. And so you can see we just have a case statement for all of our different modes, and we're going to do something different. We decided for all of our shooting ones that we're not going to use an effect. So these are all different like fancy effects that do some type of an animation. For shooting, we want it to be instant and we don't want there to be any confusion. So all we're doing is using the built-in fast LED methods of, hey, fill it solid. All of my LEDs, all 50 of them, I want it to be yellow. And this one is I'm aiming and I'm on target. We want it to be purple. And if I'm shooting but I'm not on target, it should be white. And if I'm shooting and I am on target, we want it to be green. And if I'm shooting but I don't have, my sensor says there's no more note, then I want it to be solid red. So these are really easy ways to get LED stuff working. You don't have to be fancy with different effects and animations. You can just turn on different colors. And honestly, for really important stuff that changes quickly, you'd probably just want to go solid so that it's easy for the driver or the coaches to see the status of the robot. No auto mode. This is the Beats one. This is 2 different colors. Actually, this one, again, is 4 different colors, but we're using 2 of them as red and 2 of them as blue. There's a special one for ice and a special one for fire. We just initialized both of those. So this update light pattern, this is called every loop. So I think it's every 10 milliseconds, or maybe it's even faster than that. And so if there's nothing here, case 0, we just clear it and we're done. And so we don't do any, that's off. Basically, all the LEDs are off. Both danger and intake use a pulse. So we tell the pulse to update. Has note uses beats. So we tell beats to update. All of these are solid colors. There's nothing to do in the loop. You just do nothing because you don't want to change the color. Auto is a beats, blue is ice, red auto is fire, and you just tell it to update. This is called update. We did call this one update split because the default fire starts at one end of the LED chain and goes up. We created a separate one that started in the middle and then went out to simulate fire going up both sides of our strip. We don't actually use code 20 or 21, but since the kids were working on different effects, they wanted to have it so they could test it on the little test rig. But we don't have a code for 20 or 21 in the Robo Rio, so the only way to see these is basically on the test rig. So this is the code that runs whenever your Arduino boots. This is a default thing for Arduino. There's setup. And so here's where we're going to initialize our screen. We're going to initialize our reader. That's the thing that reads the pens. We'll look at that in a minute. And then we have to set up fast LED. So we have to add our LEDs. We need to know what is the chipset. We use WS2812B LEDs. The WS2812B LEDs are the most common LEDs to buy. I have a panel sitting behind me too. Someone remind me to show you the panel before the call's over. They're the cheapest. They're the low power LEDs. They're the easiest to get. So that's the chipset that we sort of decided to standardize on. The data pen is for this particular chip setup is data pen 2. So that's the pin on the Arduino that's going to send out the signal to the LEDs that travels down the wire and lights up each individual light. And then the color order. When you buy your LEDs, some of the LEDs, actually I think most of the LEDs are not red, green, blue. I think most of them are green, red, blue, which is what these are that we have. So you have to tell Fast LED what type of LEDs you're running, and it'll be on the spec sheet or the data sheet that you get with your LEDs. This one's really important. the nice thing about fast LEDs, this is one of my favorite parts about the fast LED library, is this max power in volts and milliamps. So if you tried to light up, let's say 500 or 1,000 LEDs at full brightness, you would probably brown out because you're trying to pull too many amps, or you might actually overheat something and start smoking. So the nice thing about fast LEDs is you can set a maximum volts and amps that this thing is allowed to pull. And so since our little LED, our power converter is only 12 volts to 5 volts at 3 amps, we have this set up to allow a maximum of 5 volts and a maximum of 3,000 milliamps, which is 3 amps. This is beautiful because what will happen is if you try to light up the whole strip white, and let's say that you try to light up 1,000 LEDs white, which is full brightness for the red, full brightness for the blue, and full brightness for the green, that'll probably pull more than 3 amps. So fast LED has built-in dimming, so it'll dim all the lights so that they're still white and they're still all lit up white, but you don't pull too many amps and start making things smoke. So that's really awesome. So even if you set brightness to full brightness, a fast LED will pull all of that down so it can show you the best approximation of what you're trying to do without causing an electrical problem. So then here, initialization, we're just clearing the LEDs. So if you rebooted your Arduino or deployed new code and it used to be fire, when the thing starts up, it'll clear everything and then it'll do show to force that down the chain so they all turn off. And then here's loop. So in our loop, this is what gets called as fast as possible in Arduino. We'll call the reader and we'll say read the pins. We'll update the code on the screen, which again, if you remember, that code up above said, hey, if you've already got this number displaying on the screen, don't update the screen because it causes that weird delay and pause. And then this is checking to see if the code has changed. And if it has changed, we call the initialize light pattern with the code, and then we tell it to update the light pattern. And then we keep track of whatever the last code was. We set it equal to this new code. So that's the end of the main CPP. Let's look at pen reader because this one's really, really important. And it kind of mirrors what we saw on the RoboRio side. So this is pins that are set up for the robot. The what was that called? The Heltec chip, the one that has the built-in display. The pins are very logically numbered. So we have pins 0 through 6, 1 through 7. And then we had to jump to 19 for some reason. And I suspect it had something to do with maybe pin 8 was the pin being used for I2C. And so we couldn't use that pen because that's the one that was going to the display or something like that. The pinout that is on the UPESI W Room chip, you can see that these pins are right next to each other, but they are very much not in order. I don't know why Arduino and ESP32 chip manufacturers do that. I'm guessing there's a very smart reason for it, but you have to basically pick the pins that you've connected to your RoboRio, and these are what the pins are for the testing rig. So we're keeping track if the initialization has been completed or not. This is the little method that checks to see if the pin is quote unquote closed. And so we do a digital read on the pin. We check to see if it's high. If it's high, we return 1. And if it's not high, then we return 0. And now here's the problem is that when we're testing, we need to read low instead of high. That link that I sent in that's on the website, that'll take you to the most recent code. There's a switch in there that will take care of this automatically. But for the purposes of this talk, all we care about is all you do on Arduino is say digital read. You give it the number of the pin you want to read and check to see if it's high or low. So you have to do this is very important. You have to set up your pins on initialization and you have to give it the pin number and you have to specify whether it's an input pin or an output pin. And in our case, if the pin's floating, we want it to read high. So we're doing an input pin and we want it to pull up so it reads high. This is the method that calls all the time, every loop, and it returns an integer. And so if initialization hasn't happened, we call init. And then we do this. We say read 0 is check pin is closed. We give it the pin number, and that's our 0 through 7. And in this case, we only had, this is wrong. It's updated in the one you'll see on GitHub, but we only have 4 wires connected. So these pins, we just default to 0. And then we go through and we take pin 7 times 128, pin 6 times 164. These are either going to be a 0 or a 1. And that's how you turn a binary number into a decimal number. So that's our pin. And then if we want to look at something like, let's see, I wonder if bounce is easier than pulse. Let's take a look at this one. I wonder if pulse might be simpler. Oh yeah, pulse is way simpler. So this pulse just sends a light, a bit of LEDs back and forth on the strip. It is step -2. Let's see if we can figure out what that means. Private variable for what step you're on and your pulse color, and initializes, it looks like, to RGB, so blue, fully blue, 255. When pulse is initialized, you send in a color and you send in a step amount. If the step amount is greater than 0, then we reverse it. And the reason why we do that is because it has to do with where the pulse starts on the strip. And so I'm guessing that it starts at the end. And so we're going to make that move down the strip backwards to begin with. Let's see if that's actually what's going on here. So we do an update. This is also very important. So this every n milliseconds is a method that's built into Fast LED. And what this is basically saying is, do not go into this little block of code unless at least 10 milliseconds has passed. I almost guarantee you, if you go out on the internet, YouTube, or whatever else, and they do something where they want to do something every 10 milliseconds, they're going to do a delay 10. And what that's going to do is it's going to put your thread to sleep for 10 milliseconds. Or worse, they might do a delay 1 second or 1,000, which would be 1 second. And then you're going to put your thread to sleep for a second. Well, on your robot, if you're trying to show from yellow to I'm trying to aim to green, you're on target, you don't want to wait a second for that color to change. So you should never pause your thread. You should never put your thread to sleep. Instead, you should use this really awesome method that's built into Fast LED, and that will keep the thread alive, and it'll be constantly reading that pin as fast as it can possibly read. And your LED code will work the way you want it to work with the appropriate delay. So all this is doing here is checking to see if the pulse color.value. So what is pulse color? Oh, I see what this is doing. So this is, I think this is going from full brightness red. Oh, okay. Yeah, that's what this is. So this is the whole strip being fully, remember that the danger one that would glow on and off red? That's what pulse does. So the entire strip is the same color, but the value is HSV, so hue, saturation, value. Value is the brightness of the color. So it starts out fully red, and then we add this step value to make it either glow brighter or dimmer. And in this case, that's why we're negating the step amount, is because we're going to start the lights off fully bright, and then we're going to dim it. So if adding the step value is greater than 255, or it goes less than 10, we didn't want to go to 0 because we always wanted there to be some color. We never wanted the LEDs to look like they were off. Then we just invert the step so that we just, if we're getting dim, now we're going to be getting brighter. Or if we're done getting brighter, then we're going to start getting dim. So we just go through, we set the new pulse color its value equal to whatever its value was before, plus or minus whatever the step amount is. We tell the entire strip, fill the entire strip. Here's the array of LEDs. We want to fill the whole thing, and we want it to be set to this new color. And then you just do Fast LED show, and that will push that color to every single thing, every single LED on the strip. This is also a really easy way if you want to do rainbow. instead of changing the value, you can change the hue. And so if you go from 0 to 255 and back, then that will cycle you through all the colors of the rainbow and back by changing instead of dot value, you would say dot hue. So that would be dot hue. And so by doing it to dot hue, then that would change the actual color instead of the brightness. Saturation will change if you look in a paint program, that'll go from like gray to a color. So I'm not exactly sure what saturation would do on a LED string, but it would sort of mute your color, I suppose, if you change the saturation value. So that's how easy it is to kind of do some fun stuff with LEDs. I mentioned, if we look at Twinkle, this was the last one we did. We never put it on the robot, but here's every 1/10 of a second. What we do is this is how many twinkle lights you want. So when you initialize it, you tell it how many twinkles you want every 10 milliseconds, which is this density. And so if you're doing 10 little twinkles, you would loop from 0 to 9. And then you would pick a random number in your 50 LEDs and you would set it to this color. And then you would fade everything to black by a value of 50. And I'm not 100% sure what 50 is. I think it means that I'm not even going to guess. You'd have to look at the documentation for what that does, but it causes the LED to kind of like get bright and then start to fade out. So all of this is doing is it's randomly going to pick points on your LED, make them bright yellow or orange or whatever color you passed in, and then it'll just slowly fade to black. Or maybe it quickly fades to black, depending on how much you've got this number set to. So that's it. I mean, this is a really fun thing. I've had kids. It's really nice when you can hand the kids kind of a set of different ones like Pulse and Twinkle. Fire and Ice are way too complicated. I didn't write any of this code. You can see, Mark Kriegsman. That's where I got this code from. I copied in all of his stuff so that we give credit to the person we borrowed code from. And you can see all this crazy quadratic equation and all of this stuff in here and how to do fire. It's crazy. And he's got sparking and heat color. And there's tons and tons of things you can do with Fast LED. And if you're really smart or if you take the time, you can learn it. But even these little simple ones like Twinkle, we set up 2 students that ran out of robot code to do. And I said, here, why don't you guys play with these LEDs and come up with some new stuff? And they jumped right in. And most students can read code and sort of understand how it works. And if you give them something to start with, then they can go crazy and start making their own new modes. So I think I made one. I put in Fire and Ice because I copied in that code. And I think I may have made Bounce or Pulse or something. And the students went through and made the rest of these. So giving them a good kind of starting point and a bit of sample code goes a long ways to getting people up and running. Okay, that's it. What questions? Any questions on how this all works? Hopefully I'll get the rest of the webpage that the 2052.com/LED. I'll get the rest of that webpage updated soon, but for now, all of the links hopefully will work. Goes off to our GitHub, which will show you all of this LED code. It's actually a little bit better than this. The students made some updates that I failed to pull tonight before I started this talk. But it's up to date with everything that's on the robot right now. And then you've got the full complete singleton class for our Java code. All right, that's everything. What questions can I answer for anybody?
I've got one here. So what was the total cost of like the hardware setup for what you're running?
Oh, that's great. That's a great question. Okay, so here. Let me see if I can get this up to the screen. So this little power plug here is probably the most expensive thing on there. I think it was 10 or 12 bucks. If you buy this UPESI WRoom ESP32 chip in a 3-pack, they're $5 a piece. So $15 on Amazon. All the links are on the webpage there. This little screen is actually more expensive than chip. I think this screen was $7 when I bought one of them, but then I found it in a 10-pack and they're only $2 a piece. The little pin headers are super cheap. You buy like 50 of those at a time. The little female pin sockets, those are really cheap. And then the buck converter that's inside, that one was probably $6 or $8. There's less than $50 in this whole setup here. It's probably even less than that. And if you buy this stuff in bulk, because we have 3 setups and I'm about to make a 4th one here probably in the next week or 2, it's great because you've got a bunch of robot batteries. You have kids that run out of things to do for robot and they're looking for something fun. We don't have lights on our cart yet. I really hope we can get lights on our cart. We don't have lights on our pit. Maybe the kids will want to do that. Oh, here's the thing that I mentioned earlier. So this is the WS2812B panel. So there's 4 panels here, and I've got them stuck on this board side by side. There are libraries for Arduino that I have found, but we have not built any sample code for the students yet. But you can put, I think this is a 64 by 64. So you can take in any paint program and take Mario Brothers or Link from Legend of Zelda or whatever. And if you can get your image down to 64 by 64 pixels, then the Arduino can load it up and display that image on each pixel because a pixel is just a light. I'm hoping to get some sample code for the students, and then I can't even imagine what they're going to do with this once we get some sample code working. We also have a panel that's 32 by 128 as well, and there's libraries that'll let you do marquee signs, so you can put out the words. I've seen some robots put LED panels like this on their robot, and they do. I saw one, I think it was last year or 2 years ago, somebody had Pac-Man and the Ghost. So as they were driving across the screen, the field, they were the Ghost from Pac-Man. A lot of really fun stuff. It's a great way to get kids excited about programming, and the LED strips aren't that expensive. I mean, they're not inexpensive, but I don't even remember, $20, I think, for a 255 length string of LEDs. And I'm only lighting up 50 here. The rest of them are all on the roll still. So it's actually, I mean, if you consider the cost of like an Arduino Duo, you can do this whole thing for the price of an Arduino Duo. And the ESP32 is a dual core, and I don't even know how many megs of RAM. Way, way, way bigger than an Arduino. So it's a lot cheaper and a lot more powerful to run the ESP32 chipset.
Cool. Yeah, thanks. Yeah, we're running the whatever the Rev off the shelf, the Blinken, I think, and you know, it runs us $50-$60, and you need I suppose you don't need a Rio, but you kind of do, and so yeah, I love being able to, I don't know, give it to kids with a computer and just saying, you know, good luck basically, or make something cool. So cool.
Yeah, I mean, it was a big priority for us. First of all, we were tired of kids soldering directly to a board and, you know, causing a problem or reversing polarity or something and burning it out. And so by making sure that we only connect ground to the ESP32 chip, no power goes to this chip at all, and then all power comes through the USB cable, that made it sort of, I don't want to say foolproof, but it really made it much simpler and safer to put something in the hands of a student and not have to have them not have to worry about, you know, bare wires or being cooked up wrong or anything like that. And as soon as you can give it to a student, and, you know, and some students not too excited about having to do anything where wire, I mean, this looks like just a standard plug for them, right? They're like, oh yeah, I can plug stuff in. But if they had to wire something, they get really scared about it. And so comfort level wise for new students, we're very happy with it. It's been great to get kids who run out of things to do, give them something fun to do. All right, we've got 10 minutes left. Does anybody have any final questions? Otherwise, John, if you're still around, I'd love to hear your update on state rankings. Let's see. Any last questions? All right. Send me, you guys all have my contact information because it's on it's on the website. You can send it to info@team2052 and it'll get to me, but I think most of you have it because of the sign up form for the weekly meetings. So send me any questions. We'll try to get that webpage updated later. And with that, I'll turn it over to John and anybody else who wants to share an update on how last week went for them, or if they have any questions in general about competition or champs or robot damage. Let's talk about robot damage. All right.
Yep. So when it comes to states, I have a preview here of the state rankings. We are still going through the process of validating them. I expect them to be posted sometime tomorrow, once more members of the committee have had a chance to take a look. But as far as I could tell, these should be good to go. So you guys can sort of see how things worked out. That 33-point cutoff is actually a straight cutoff. The 37th team is sitting at 32 points, so we don't have to go into any of the tiebreakers.
So 30 points is what it takes, John. Is that right? Did I understand
33.
that? 33. 33 is what it takes to qualify. And is there anyone left to qualify? That was this weekend was the last weekend, right?
Yep, this weekend was the last weekend, so everyone has now competed. It was kind of interesting. You know, we had one team doing their first at Seven Rivers, and then a bunch up at Granite City, and none of them made it. But we had two teams from 10,000 Lakes who made it in. So it certainly does seem to pay off to compete earlier in the season. I think a lot of second plays here late in the season take up a lot of those points, make it a lot harder to get those points in if your first play is here in week 6.
Does anybody have any, in the last 5 minutes here, does anybody have anything they want to share about how their weekend went, if they competed, or any questions or topics they want to bring up? Maybe something to discuss for the future week?
I guess I just open it up, Seth. Is there anything on code side or programming that anyone's interested in? Our team's probably looking to do. We'd be interested in hosting or doing another one, a deeper dive into something, or I don't know, kind of open invitation. So,
Sam, are you guys doing anything with note tracking, object tracking for notes?
we're not. That's a summer project, maybe, possibly. Yep, nothing here. Sorry.
We did PixieCam a few years ago and we did PixieCam tracking for 2020, and then we never really got to use it. Just used it a little bit. It wasn't ready to go for our first regional, and we were looking forward to plugging it in for our second regional, and then things got canceled. I don't know if we're going to get to that before Chance or State. I suspect no, but I think it'll be a summer project for us to either do PixieCam and probably both PixieCam and the AI machine learning stuff in Photon Vision, and see which one works easier and better for us. I'd be interested in seeing what teams are doing for that, if they're doing object detection. I had a few students ask us about that in our pit, and we had to tell them that we hadn't gotten that far yet. I have a question similar to that. I started last summer a Blue Alliance kind of scraping app that would go through and pull out stats for teams in Minnesota. And I was able to get all of the data down, competition data down and cached, but then I never went back to it and started pulling out statistics. I'd love to get an idea of all the teams that have won Chairman/Inspiration Award. I think that would be cool for our students to see. I think it'd be neat to be able to see if teams are consistently winning the quality award or the engineering award. It'd be neat to know who are the teams that you can talk to about things like that. But I was thinking about maybe doing another coding talk around the Blue Alliance API and how to use it, if anyone's interested in that.
That would be wonderful.
Okay.
I would enjoy that.
Okay. I pulled this one together on the skin of my teeth, and it actually is even complete. But I'll try to pull something together for that in an upcoming call, maybe before summer. It actually could be a great summer project if you're trying to do things with your students over the summer. Doing a Blue Alliance coding project could be a fun thing to do.
There's a Chief Delphi post where they were doing about quinfecta or hexfecta, like
hexafecta, but
whatever.
Yeah.
It did that for every team ever in the whole world. So we were looking at ours. So someone did that for all of them, but not just from. I mean, didn't restrict it only to Minnesota.
Yeah, I was doing it for Minnesota because I was trying not to cache the entire Blue Alliance. But once you've done it for some, you could let it run overnight and do it for the rest, I suppose. Yeah, we ended up, whatever that thing is called, we ended up winning that, finally accomplishing that a few years ago when we won the creativity award. That was our last robot award to win. That's really fun to get those kind of stats, which is why actually that when we did that last year or 2 years ago, whatever it was, that was what kind of prompted me to say, hey, who else has done this? And so I know that somebody else has already done that, but I thought, what other interesting statistics can I pull out that our students would enjoy? Maybe get them excited enough to go out and start building their own Blue Alliance apps, or at least pulling stats from them. And now Blue Alliance has so much data for each game. There's so much data you can get off the actual game, right? I mean, that's how StatBox is getting all that data. So getting your students who are into statistics and math and all of that stuff, and then teaching them how to use the Blue Alliance, it could be really cool to see what they're doing. John, did your robot break in half this past weekend?
Nope, it stayed together. We did notice a crack starting to form in some of our half-inch polycarb again, though. So there's some flaw in the design that's putting too much stress on that piece. So it cracked in our first week event too.
John, I've been meaning to ask, how are the Krakens working out with the Rev Swerve?
Oh, they've been working great. We didn't actually have any issues with them at all the whole season.
Nice.
So, John,
did you think? Oh, sorry, go ahead, Scott.
Did you have to use the WPI lib then from scratch, or were you able to still use the Rev libraries for Swerve with the Krakens?
We used the Rev libraries, but we had to do some modifications.
Oh, okay.
Non-technical mentor here. What's the advantage?
Shipping primarily.
Oh, okay.
we had Krakens, we had Vortexes, and we wanted to use one of those two, but we couldn't get the shafts we needed for the Vortex, but we could get what we needed for the Krakens. So,
gotcha.
We could get everything together a little bit quicker that way.
And you had to machine custom parts to make an adapter or something, right?
We had to 3D print a spacer to hold the Kraken up slightly higher because of the boss on it. And so once we got that up, we bought the pinion gears from West Coast Products, but those are a little more than twice as big as you need. So we cut them in half and then finished them off on the mill so that they were the same height, cut some little spacers, tacked as that spacer up against the bearing, and then could assemble the whole thing.
Yeah, we're looking at doing a similar thing. I don't know if we're running the Vortexes this year, and I don't think we're getting the acceleration the Kraken teams are getting, so we're going to at least experiment with it. I mean, I could be, I don't know what the word is. It could be superstition or something, but we're like 85 pounds and we're watching these 125-pound things just fly. And we're not sure if that's the magic sauce, but we're suspecting. So
I also wonder what gear ratio they're running too.
Right. Yep.
Yeah, I saw Fire Bears, man, I think they were the fastest bot on the field at 10K. They were screaming across the field, and they're running Rev with Vortexes. I don't know what they got on there for gear ratio, but man, they had a fast bot.
Okay, I'll have to double check. Well, we ran the fastest at Lake Superior, but our acceleration was junk, and so we're trying to figure out, I don't know, that balance, that mix, or is it mechanical? Is it the motors? Is it, I don't know what else code?
Yeah, there is a balance between gearing for speed versus gearing for acceleration. The more speed you get, the worse your acceleration is.
We had our first Kraken burnout on us on Tuesday night. We were just about to quit for the night and then pack the trailer after school on Wednesday, and Kraken would no longer drive forward. It would only drive in reverse, but it would only drive in reverse if you were trying to drive forward. So
that's weird.
Swapped it out, and the new Kraken, and you just put in the CAN ID and then everything was fine. But it was a 2-hour swerve module, well, debugging too, but 2-hour swap out a swerve module. And then unfortunately we also had to beef up our super frame. So we have our frame and then we have a frame above that to support the bumper, and that beefier frame was covering up the bolts. So it made it a little bit trickier to get the swerve module out, but luckily that was the answer. We swapped out the motor and everything was fine. So we're not sure. That one motor got really hot. It was very hot, significantly hotter than the other three. So we're not sure why one of our three motors got extra hot. I think the obvious thing is that, well, maybe it was misaligned or something, but we put the new motor in and the wheel was perfectly straight. So it wasn't a CAN coder offset issue. I don't know. Just that one motor got too hot and stopped working. Well, I don't think we took a lot of damage. I don't know how everybody else fared this weekend, but I don't know. Maybe damage was less than usual, but I feel like we had less damage than we had at Lake Superior. We also put a ton of extra support into our frame and stuff, but I don't know. It seemed like it wasn't nearly as bad as it was that first weekend. Maybe our driver was a little bit more cautious too. I'm not sure. All right. Well, we're past our time. Any closing comments or last questions before we go? Tomorrow, if all goes to plan, Michael Flood will be leading our conversation next week. So No Mythic is going to be giving our chat next week. All right.
Thanks.
Thanks for all the work,
everybody.
Scott. Thanks for that obviously took a lot of time. So thank you.
Yeah. Well, and I didn't even get it all done. I'll try to get it updated soon, but hopefully it's enough for everyone to get started if you're interested in doing it. We're very happy with it, and hopefully it'll help you too. All right. Have a good night.
Thank you. Bye-bye.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.